So I'm very, very excited to share the stage with four stunning humans. We have George, James, Joe, and Chad, and each are going to bring a slightly different perspective to 5-MeO research. George and I will be starting the first session, and the main focus will be on some of the neural findings from our project we ran last year in Mexico. But before we dive into it, we thought it would be good to kind of set the scene a bit. George made a very good point when we were planning this study, planning this presentation, that of all of the crowds we're speaking to, we probably don't need to explain 5-MeO that much because many people will already be familiar or quite familiar with the molecule. But in case anyone doesn't know, I thought I'd do a quick 30-second just overview of what this molecule is. So it's a very short-acting, powerful psychedelic. And in its vaporized form, it's only been around for the last couple of decades. And it can be derived from the toad, and you may have heard it called bufo, or it can be in its synthesized form known as the pure molecule, or JAG. And in our research, we used the synthesized version. Now, the subjective effects of 5-MeO are quite different from other psychedelics. People often describe being obliterated into pure consciousness or seeing the white light. It's this kind of non-dual experience. And James is going to speak more to the specific phenomenology. But for now, I've got a couple of slides to just characterize some of the quotes. So some of these quotes really go into detail, and I won't read through all of them, but I think the second one is quite nice to kind of characterize it. From Andreas. So right away, you are forced to become a point, or pure space, or light, and it's impossible to know in any way, shape, or form that you are ever a human. You are an elemental force of nature, completely surrendered to a powerful energetic currents of the universe, but you will never be able to remember this well. All you can do is live it. So that's some food for thought. And another thing to know is it is also colloquially known as the God molecule. So without going into too much detail, this is kind of the substance we're talking about, and you can already see it's slightly different from other psychedelics. So this sounds like a very cool experience, and a couple of years ago, George and I were planning the study, and we realized there's very, very little research on it. There's been some naturalistic work, but we really wanted to know more about both the neural and subjective effects. And back then, and even now, there's no published human studies on the neuro side of things. So we're here to tell you a bit more about the project we ran last year in January. And yeah, pitching a talk to Breaking Convention is surprisingly tricky because obviously there's a very mixed bunch of people, and usually we're presenting to like a very specific group. So as any self-respecting academic does, I thought I'd reach out to some of my friends in the space to see what would you actually want to hear about this study, what would be kind of interesting and useful before we jump straight into the neuro. So I asked my friends, and obviously I've been yapping on about this study for the last 3 years, and they've had many conversations about the design and outcomes. And so I was pretty humbled by some of their responses. Clearly those conversations sank in. So probably a good place to start is what we actually did. So I think it's important to say, when we were planning this, me and George were very much like baby PhD students. We didn't want to pretend we had the kind of facilitation or skills to be able to serve this kind of substance to people, especially not in our lab, which back then didn't quite have the infrastructure to hold this. So we really wanted to collaborate with people who did have the know-how of how to serve it and how to work with this molecule. So we were put in contact with Joel and Victoria from Tandava Retreats. And from our first conversation with them, we knew they were the perfect people to collaborate with. They were incredibly open to research, advocates of education, had been serving this substance for years, decades between them. And so we just shared the same vision of bringing a very safe and informed and thorough sort of approach to this research. And so we went out to Mexico to visit them and vet their protocol, and it was incredible. And as soon as we came back, we knew this was the place we wanted to do our research. And one of the key active ingredients throughout the kind of design process was bringing the same kind of rigor and standardization that we have within the lab, but bringing the lab to Mexico. So rather than conducting just a pure naturalistic study where we'd kind of join in on their retreats, we really wanted to set up a series of specific science retreats where we could keep things well, we could kind of get the best from both worlds. So having that standardization, having that rigor, but also bringing in their wealth of knowledge in terms of setting, facilitation, which is actually very specific to 5-MeO. And so we came back and we planned this study. And this, you can't really see it, and I won't go into too much detail for the sake of time, but essentially we planned 6 separate retreats with a maximum of 6 participants per retreat, each retreat lasting 3 days, with a preparation day, dosing day, and an integration day. And over the course of these talks, George is going to speak a bit more to the neural findings, and we also, in addition to collaborating with the retreat center, Tandava and F.I.V.E, we also wanted to collaborate with other research institutes. So we invited James along to be our microphenomenologist to really get a deeper understanding of the subjective effects. Rather than just giving kind of blanket questionnaires, we wanted to dive deeper into the experience to match the kind of rigor we were bringing to the neuro side. And we also collaborated with other researchers at UCL, such as Jo, who will be speaking more about the linguistic side of things with the chatbot she developed. So it really was a collaboration within and between institutions. We wanted to bring that to it. We didn't think we knew how we could do this alone, and so that really was another one of the active ingredients. So another quick question that some of my friends were asking was, like, how do you do EEG in the field? Which is a pretty good question, because we did want to bring the lab out. Now, usually, we just conduct things in the lab, but you can have kind of remote portable EEGs. But one thing to consider is that when conducting EEG, obviously you have this cap and you get this signal, but you can get artifacts from even the smallest of things. So this is just an indication where you see the arrows of just blinks. And obviously when it comes to 5-MeO, blinks are kind of the least of your worries, because it's known to be a very, very dynamic experience for some people. It can lead to vocalizations, screaming, movements, tremors, full body releases. So actually, one of the things we also had to think about are the kind of people we were recruiting to participate in the study. So we actually had like a 4-stage screening and recruitment protocol where we really wanted to recruit people who had taken 5-MeO many times. That was kind of a safety side of things, and also who had experience of staying still. This is obviously quite flexible. Some people remain completely still, and in the field they're known as Buddha sitters. And so that was kind of the target population we were looking for. So this is very niche, and many people do move, but we were specific mainly because we wanted to get that good EEG signal. The second thing to think about is usually in the lab we have this gel set up, and this can take up to an hour to set up. And because we had this very specific protocol where we had the 6 retreats, in one day we were dosing up to 6 people. And so we feasibly couldn't use an hour to set up. So we invested in some saline net caps, and these take around 5 to 15 minutes to set up. And it's very easy. We just kind of had to dunk them in potassium chloride and kind of baby shampoo, make a concoction, and then they were ready to go. Obviously, we had to bring all of this equipment out, and we were dosing around 30 people. And just to make it clear, it looks kind of exactly how you wouldn't want it to look when crossing over the border to Mexico. But it is just salt. There was no smuggling. And we did get there, and we managed to run our study, and here's a few images of the setup. We have Victoria in the corner using the argon gas piston vaporizer to set up the 5-MeO, and a couple of snapshots. And I'm not going to go into too much detail because I want to pass over so you can hear a lot more about our findings. Now, just to be candid, many people did want to know a lot more about what happens, and I think James is going to speak to a lot of these. But many people did want to know about all the nerdy science of it. And I think this is probably the perfect time to hand over to George, who's going to go into what it does to the brain. So we'll go over to George.
Hi, guys. So yeah, I'm going to talk about the nerdy science of it all. I've got a lot of results to get through, so hopefully you'll stay with me. I'm going to start by taking a brief detour around the rat brain. Let's make it a bit taller. So I think this is interesting, not just because I think it's interesting to try and understand how systematically these drugs affect brains across the phylogenetic tree, but Also because this was really the only stuff that was out there before we did our study. So, we found this really peculiar effect in mice, and that's the enhancements of low-frequency oscillations. You can see from these top rows here, yeah, maybe I'll take it out. So you can see from these top rows here of these plots, the LFPs, or local field potentials, which are basically the summation of neural activity from thousands of neurons. And you can see that in the 5-MeO DMT case, it seems to lock into this slow, cycling, low-frequency, rhythmic groove. I mean, if you were to play this kind of waveform as an audio file, it would sound very bassy. It would sound potentially like a dub track or something. So that's a really peculiar thing to see in a brain, because when we see that, it's usually a sign that someone or an animal has gone to sleep or has gone undergone general anesthesia or has had a traumatic brain injury, is in a coma. But we see this under 5-MeO DMT, while these mice are awake and aware and freely behaving. So what's going on here? I mean, so these researchers came up with this term paradoxical wakefulness, to have a symmetry with the concept of paradoxical sleep, where brains look awake, but the animal is asleep. Here, brains look asleep, but the animal is awake, aware, moving around, freely behaving. Okay, so what happens in the human brain? Remarkably, we found exactly the same thing. So here's a spectrogram where 0 is when they inhaled their 12 milligrams of 5-MeO DMT. And you can see this red here, which is basically these low-frequency oscillations massively increasing and then returning to baseline at around 8 or 9 or 10 minutes, which is exactly when the experience is starting to cease and they're coming back into the room. So you can see this more starkly here, where the purple line is 5-MeO DMT. You can see in the top left portion of the graph, where the line is starting to dovetail up and dovetail away, that's those low-frequency oscillations massively increasing at the peak. And you can see this topographic plot here, which shows that those increases in low-frequency oscillations are really spatially diffuse. They're spatially distributed throughout the brain. So it's a really strong effect. One of the most interesting things about this graph here is that this middle bump, this little section in the middle, the so-called alpha oscillatory peak, is generally a really reliable sign that someone's tripping, that deflates. But we don't see that here. We see that pretty much exactly the same alpha oscillatory power. I mean, that's the case on pretty much every other psychedelic that's been tested so far, and we don't see that effect here. What we do see is this increase in gamma oscillations here, or late beta, these high frequencies at the end in the bottom right portion of the graph. But actually, we can cache those out also in terms of these low frequency oscillations. So these carrier frequencies, these higher frequency rhythms, themselves receive greater amplitude modulation at lower frequencies. That's to say that basically these high frequency oscillations are themselves oscillating at low frequencies. So the point being here is that slow really is the kind of start of the show. Okay, so we replicate these mouse findings in humans for the first time. And the reason this is interesting is because everyone previously thought that low frequency oscillations were a sign of loss of consciousness. But something that 5-MeO DMT shares with all of these states is potentially that not that the capacity for subjective experience is ceasing, but our capacity to have an experience that contains or is informed by or has content exported from the external world, but perhaps the capacity for that is reduced. In other words, you have an episode of disconnected or isolated consciousness. Okay, but everyone here is probably thinking 5-MeO DMT is nothing like sleep or general anesthesia, right? If it looks the same from this simple oscillatory perspective, how can we understand its difference? And I'm going to make the partially theoretical but mainly empirical argument here that the way to do so is in making a distinction between oscillations and waves. So many of you, when you will hear some neuroscience talks, you'll hear of delta waves, alpha waves, all of these kind of waves. And it's not necessarily incorrect to refer to them as waves, but it's not even the way we kind of colloquially think about waves. So in the space of all oscillations, we have waves. That is to say that all waves are oscillations, but not all oscillations are waves. When we think about waves, we think about this Turner painting here. We think about some three-dimensional object that's moving around, jumping up into the air, crashing on our feet, dancing about in the sun. Something that is a fundamentally three-dimensional thing that propagates itself in space and time. It crashes and whirls and has these vortices. When we think about an oscillation, we think about something that is fluctuating, but it's doing so in merely in some kind of amplitude space over time. Whereas with a wave, we're thinking about something that's propagating in space and time and in an amplitude. So I think this is important because it tries to get at the kind of native dimensions in which brain activity likes to express itself and have hopefully a more comprehensive picture of brain dynamics. So the way we operationalize that here is by importing some of the mathematics from fluid dynamics and basically treating the electrical potentials of the brain as if they're a fluid propagating along the continuous surface of the cortex. And we get at these nice mathematical tools like velocity fields and blah, blah, blah. And yeah, hopefully this might provide some details as to why 5-MeO-DMT is different. So getting into it, first of all, we find that global coherence is massively decreased for these low frequency oscillations. That means that they rise and fall a lot less together, they're less synchronized. We also find that the variance in this over time is massively reduced. That is, the tendency to move between these periods of synchronization and desynchronization is also reduced. So between these tendencies of integration and segregation. That's the case globally when we consider all the possible interactions in the brain, but it's also the case locally when we take a single point and then we examine its relationship with its neighbors. So overall, we observe a temporally persistent local and global low-frequency desynchronization. Now, this is point one of distinction with states of unconsciousness. They show precisely the opposite effect of everything starting to work together a lot more. Here, we see a much more competitive or segregated type of behavior. Really trying to exploit the wave formalism a bit more now, we see that waves flow faster across the cortex. But they're not doing so collectively. There's not some kind of collective tidal wave that's happening. Actually, it's a really spatially circumscribed, disorganized type of flow. Things aren't swooping across the cortex in the way that they used to. That's emphasized here by this heterogeneity metric, showing that the kind of heterogeneity or diversity of wave speeds, wave directions is also massively increased. Really exploiting the wave formalism, we can get at some viscosity. We can get a measure of the magnitude of resistance to flow in the brain. And that also increases. So you can think about not only is perhaps the brain like a bassy dub tune, but it's also like a viscous, oily liquid. So we have disorganized low-frequency flow with diverse local patterns limiting the emergence of global propagation. Again, the opposite of what is seen in states of anesthesia, sleep, etc. Okay, so we've said that everything is becoming disorganized, but where is it all going? Usually, under resting state conditions, when you're waking under normal consciousness, waves love traveling forwards and backwards across the cortex, so-called feed-forward and feedback waves going up and down the cortical hierarchy. Here we see a massive deflation of both of those things, and waves start to travel in these more chaotic intercardinal directions. We also find that they recur less over time. These are recurrence matrices, which basically measure the kind of similarity of patterns over time. And you can see that the 5-MeO graph is a lot more spread out. And it has this kind of core periphery architecture where these nodes on the end are all unique patterns that are rarely, if ever, revisited. So you have this chaotic nature of these slow wave patterns. Wave patterns also have reduced lifetimes, kind of implied by this last slide, where when we taxonomize waves into all their possible different types, all of them pretty much reduce in their lifetime. They become shorter, they become ablated quickly, they can't live out their happy wave-like life in the brain for very long. Okay, so 5-MeO-DMT reorganizes complex low-frequency waves. Waves become incoherent, heterogeneous, viscous, fleeting, non-recurring, and to cease their travel up and down the cortical hierarchy, the opposite of what's seen in states of unconsciousness. Okay, that seems like an easy goal to try and differentiate 5-MeO from states of unconsciousness from the perspective of the brain. How can we try and understand it on its own terms, perhaps getting at some of the concepts that are slightly aligned with the nature of the phenomenology of 5? So, first of all, we see that kind of implied by the increase in these slow potentials in the brain that the intrinsic timescale of the cortex massively increases. This is an indication that the brain is becoming more stable. It's able to integrate information over longer windows. It's becoming locked into a certain particular groove for a period of time. We also find that the separation rate goes down. That's a kind of measure of chaoticity or sensitivity to initial conditions. It's basically a measure of taking 2 points that are similar in their activity profile, following them along in time, following their trajectories, and seeing how quickly they diverge. It's basically a measure of how quickly and how much do points of neural activity like to explore their possible repertoire of states. And we find that to go down. So another indication of stabilized dynamics. We found a consequence of this in the fact that the dimensionality of brain dynamics goes down. So this is from a PCA, which basically is how easily can we explain brain dynamics? So this decreased dimensionality means that we need fewer parameters, fewer dimensions to explain brain dynamics. Brain dynamics, in a sense, have collapsed onto some simple manifold that become easy to explain. We find a consequence of this also potentially in the idea that brain dynamics are on a steepened energy landscape. In other words, because of all of these changes, it's harder for the brain to orchestrate large-scale amplitude deviations. Indeed, we find that the energy landscape of the cortex increases. That is to say that the brain is again getting locked into this stable state that is on a lower dimensional manifold, that is simple, has all these extraneous details deconstructed, and where it's hard to orchestrate big, rapid shifts. Cool. So why is this interesting? I think it's interesting because it starts to get at some of the concepts that Andres Gomez-Emilson has spoken about with reference to F.I.V.E. So I've got this slide here, which is, imagine you're looking at this beautiful seascape. And these points on this graph are sensory data that your brain is trying to explain. Your brain is trying to model those points. When you're awake and sober, your brain is pretty good at making a nice, simple, and elegant model that's actually good at explaining the data. As emphasized here by this kind of simple line, it's a swooping curve, and it seems to accommodate all of those points pretty well, right? Under F.I.V.E, consistent with this idea of a collapse of the dimensionality, being locked into a stable state, this remove of extraneous parameters, we see a thing called underfitting. Underfitting is the language of machine learning, but it basically means that you're using a very simple model, a very simple line to try and describe your data, which is why your experience of the world might look something like that. And the other tendency is DMT. We are overfitting a model. We're using this incredibly complicated line to describe a set of data that could be described very easily. Cool. So that's it. The conclusion is diffuse amplitude, low frequency oscillations. We replicate that in humans for the first time, like it's been seen in mice. We see radically reorganized, complex, slow wave patterns, the opposite of what is seen in states of general anesthesia. And we see reduced state-space exploration of neural activity. And I think hopefully what comes across from this is the potential to look at 5-MeO as an instance of a, quote, underfitted brain. So yeah, this resulted from loads and loads and loads of people's work. So thanks to all of them. Yeah, I'll take some questions now.